Have you ever wondered how laboratory techniques are performed? Well, you're in for a treat. Today, we delve into the fascinating world of laboratory techniques, the unsung heroes of scientific discovery and innovation. We'll be exploring a variety of techniques that scientists use to make accurate measurements and observations, and to carry out complex chemical reactions. First, we'll get to grips with the calibration of thermometers, a simple but crucial task that ensures temperature measurements are as precise as possible. Then, we'll tackle the concepts of melting and boiling points, which are fundamental to understanding the behavior of different substances. We'll also discover the intricacies of distillation, a process used to separate mixtures based on differences in their volatilities. Finally, we'll demystify the process of recrystallization, a method used to purify substances. These techniques may sound daunting, but they're the backbone of many scientific experiments. Stay tuned to understand how these intriguing processes unfold in a lab. Diving right in, the first laboratory technique we will explore is the calibration of thermometers. Calibration is a critical process in the world of science. It's a way of checking the accuracy of an instrument, in this case, a thermometer, and adjusting it to ensure precise measurements. Calibration is crucial because it provides a means of verifying that your thermometer is reading correctly. It's like making sure your compass is pointing true north. Without it, your experimental results could be off course. The purpose of calibration is to eliminate or reduce bias in the instrument's readings over a range for all continuous values. It's about ensuring that the measurements you take are as accurate as possible, no matter the temperature. So, how do we calibrate a thermometer? Well, the process can be as simple as a two-point check. The first point is at the freezing mark, 0 degrees Celsius, and the second at the boiling point of water, 100 degrees Celsius. For the freezing point calibration, we need a container filled with a slurry of crushed ice and water. The thermometer is placed into the mixture, ensuring the sensor is fully immersed but not touching the sides or bottom of the container. After about 5 minutes, when the reading stabilizes, it should read 0 degrees Celsius. Now, for the boiling point calibration. We need a pot of boiling water, making sure we're at sea level since altitude affects the boiling point. The thermometer is placed into the boiling water, again ensuring the sensor is fully immersed but not touching the sides or bottom of the pot. Once the reading stabilizes, it should read 100 degrees Celsius. Keep in mind, if the thermometer doesn't read accurately at these points, it may need to be adjusted or replaced. Now that we understand thermometer calibration, we can ensure accurate temperature readings, a critical aspect of many experiments. This way, we can be confident in the accuracy of our results, and our scientific journey continues on the right path. Moving forward, let's delve into the techniques of determining melting and boiling points. These 2 points are vital in understanding the physical properties of substances and are key to identifying unknown substances in the laboratory. First, let's talk about the melting point. The melting point is the temperature at which a substance changes from a solid to a liquid state. It's a unique characteristic of a pure substance and varies from one substance to another. In the lab, this is usually determined using a device called a melting point apparatus. We start by placing a small amount of the substance in a thin-walled capillary tube. The tube is then heated slowly, and the temperature at which the substance begins to liquefy is recorded as the melting point. On the other hand, the boiling point is the temperature at which a substance transits from a liquid to a gaseous state. Like the melting point, the boiling point is a distinct property of a pure substance and can be used to identify it. To determine the boiling point, we heat a liquid in a container and measure the temperature at which it begins to boil. The temperature at which the liquid starts to transform into a gas is recorded as the boiling point. In both methods, it's vital to heat the substances slowly and carefully to avoid superheating or overheating, which could lead to inaccurate results. It's also crucial to remember that these points can be influenced by factors like pressure. For instance, the boiling point of water decreases as we move to higher altitudes where the atmospheric pressure is lower. Understanding these techniques and the science behind them is not just about numbers or temperatures. It's about comprehending the nature, behavior, and characteristics of substances. It's about understanding how they react under different conditions and how we can use this knowledge to identify them and predict their behavior. With the knowledge of these techniques, we can identify substances and understand their properties. Next on our list is the fascinating process of distillation. If you've ever wondered how to separate mixtures or purify substances, then distillation is the answer you're looking for. It's a laboratory technique that's as intriguing as it is useful. What is distillation, you might ask? Well, it's a process that exploits the differences in boiling points of substances. It's a simple yet elegant method that allows for the separation and purification of substances in a mixture. To give you an idea of how this works, imagine having a mixture of two liquids, say water and alcohol. These two have different boiling points, with alcohol boiling at a lower temperature than water. In a distillation setup, when we heat the mixture, the alcohol will start to boil and vaporize first. This vapor is then directed into a condenser, where it cools down and turns back into a liquid, effectively separating it from the water. Now, this was a simple example. In reality, distillation can be used for a variety of mixtures and isn't limited to just liquids. It's a versatile technique that's widely used in industries like petroleum refining, food processing, and even in the production of alcoholic beverages. But let's dial it back to the lab. In a lab setting, you'll typically see two types of distillation: simple and fractional. Simple distillation is what we just discussed, used for substances with significantly different boiling points. Fractional distillation, on the other hand, is used when the boiling points of the substances in a mixture are close together. It involves a fractionating column that provides multiple condensation and vaporization cycles, leading to a more effective separation. So, there you have it, distillation. A technique that's both simple and complex depending on the situation. It's an indispensable tool in the world of science, allowing us to understand and manipulate the substances around us. Distillation, a versatile technique, allows us to separate and purify substances, enhancing our lab capabilities. Finally, we explore the technique of recrystallization. This is not just a science experiment you might remember from your high school chemistry class. It's a fundamental laboratory technique used extensively in the realms of chemistry and biochemistry. But what exactly is recrystallization? Simply put, it's a process used to purify a solid. It's all about separating a solid from its impurities. This might sound like a magic trick, but it's pure science. The magic lies in the science, my friends. Now let's get a bit more specific. The process begins with dissolving the impure solid in a hot solvent. The choice of solvent here is critical. It needs to be one in which the solid is soluble at high temperatures, but less so at lower temperatures. Once dissolved, the solution is then allowed to cool. As it cools, the purer solid separates from the solution, forming crystals. These crystals are then collected and dried. Voila! You have a purified solid. In the world of chemistry, this method has a multitude of applications. It's used in industries ranging from pharmaceuticals to food production. For instance, it's used to purify raw sugar in the sugar industry and to obtain pure compounds in pharmaceutical industries. So how do we perform recrystallization? Well, the first step is to choose the appropriate solvent. Once that's done, the impure solid is added to the solvent and heated until it dissolves. The hot solution is then filtered to remove any undissolved impurities. The filtered solution is then allowed to cool slowly. During cooling, the purified solid starts to form crystals. These crystals are then collected by filtration and dried. The magic of recrystallization lies in its simplicity and effectiveness. It's a process that allows us to separate the pure from the impure, the wanted from the unwanted. It's not just a technique, it's a metaphor for life, if you think about it. Recrystallization, a key technique for purifying solid compounds, completes our practical lab toolkit. So, let's keep this tool polished and ready for the next time we need to purify a solid. We've journeyed through some essential laboratory techniques today. From the precise calibration of thermometers, the critical first step in any scientific experiment, to the identification of substances through their unique melting and boiling points. We've also dived into the art of distillation, a technique used to separate mixtures based on differences in their volatilities in a boiling liquid mixture. We can't forget recrystallization, a method for purifying substances based on differences in solubility. Each of these techniques is a fundamental pillar of laboratory science, with its unique importance and process. They are the tools that transform curiosity into knowledge, the nuts and bolts of discovery. Remember, mastering these techniques opens new doors in your scientific journey. Every experiment you conduct, every discovery you make is a step forward in the grand adventure of science. So continue exploring, continue questioning, and continue learning. Subscribe for more.